So, what I want to talk about today is fronts. So, hopefully, this little video is going to help you be able to fill out the notes that I sent you on fronts. So, in general, we know what fronts are. We have these symbols for them, and they are the boundaries between air masses. So, here's the weird part: air masses, like, let me look at the next slide here, cold air meeting warm air. You would think since it's all air, it would mix easily, but the reality is it does not, because the cold air has a different density than warm air. It's kind of like oil and water have different densities, so they don't mix very easily. So what happens is the less dense fluid, in this case the warm air, gets shoved up. So along fronts, you always get this slanted shape as the warm air gets pushed up and over the cold air. Now, we're going to go through each type of front to kind of give you some of the specifics, and some of this should sound familiar because we've talked about it before. We're going to start with cold fronts. Now, a cold front has a steep slope. Okay, the cold air is pushing into this warm air, and as it pushes in, it moves really fast. Cold fronts move quickly. So as it moves quickly, it's going to shove this warm air up quickly. And when you push air up quickly, it forms cumuliform clouds. Like this one is obviously a cumulonimbus cloud because you can see the rain and lightning coming out of it. So cold fronts tend to be where we get thunderstorms and we get heavy rain. Now, on a positive note, the clouds, as you can see right here, don't form over a super wide area, at least as long as you ignore the cirrus clouds. The real heavy stuff is a very narrow area because as you push the air up quickly, it does not have time to spread out. So, although you get really heavy rain right here because of the quickly rising air, it doesn't last very long because A, the cloud band is not very wide, and B, this front is moving quickly. So, this narrow band of rain moves past fairly quickly. That's cold front. A warm front, you can see, is a slightly different picture. This one has a much more gradual slope. Okay, the warm air is trying to push up and over this cold air, but it doesn't really have any ability to move the cold air, so it has to slowly go up and over it. And you know, as it goes up slowly, what kind of clouds are we going to get? Stratus type clouds. Down here, if they're raining, they would be nimbostratus or just plain stratus. Up higher, they'd be altostratus. Up further would be cirrostratus. And occasionally you get cirrus clouds way up at the top. So in a nutshell, warm front, gradual slope, air rises slowly, you get stratus type clouds. And when the rain's coming down, you'll notice it's spread out over a wider area because the clouds are spread out over a wider area, and the rain falling is much lighter. In a cold front, the droplets hit each other and become big, which makes them fall fast. In this warm front, however, the droplets are more spread out, so they don't get bigger, so they don't fall fast. So you get light rain. Now, a stationary front, if I were to show you a side view, it would actually look like this guy. Stationary fronts tend to have a nice gradual slope. They don't always, but they tend to. As a result, stationary fronts usually have air rising slowly, which gives you stratus type clouds, and you usually get a wide band of it. Now, sometimes you get rain over on the cold side, sometimes it's on the warm side, sometimes it's spread out over both. Stationary fronts are a little more, I don't want to say unpredictable, but it's harder to draw exactly what each one is going to look like. So for now, we'll just say it has a gradual slope and looks a lot like a warm front, except it's not moving. An occluded front. An occluded front is a weird one. And so we're going to look at this picture up here at the top first, okay, which is actually the last thing on your notes to fill out. So we start with our typical low pressure center in the United States with a cold front headed south and a warm front headed north. As it moves to the east, the cold front is going to start to catch up to the warm front because, as I said, cold fronts move fast. Warm fronts don't. By the third picture, you can see the cold front is starting to catch up to the warm front. And when it does catch up to the warm front, they kind of merge and become what's called an occluded front. So what does it look like? Let's look at the picture down here. The cold air, so I'm going to use my cursor, watch this. This cold air right here catches up to the cold air up here. And what happens to the warm air in the middle? It gets shoved upwards right here. So the cold air catches the cold air, shoves the warm air up. Now, it doesn't go up super fast. It doesn't go up super slow. So sometimes you get stratus clouds. Sometimes you get cumulus clouds. Sometimes it rains. Sometimes it doesn't. Sometimes it's kind of heavy, but usually it's pretty mild. You generally don't get severe weather with an occluded front because the air doesn't generally go up very fast. Because the rule of thumb is if air goes up fast, it comes down fast and you get severe weather. An occluded front, you don't have air going up fast, so you generally don't